Hi, this is another video from Alex, and in this video I'm going to show you how to test PLC alarm logic with PLC Logic Prover. So we're going to use exactly the same application like we used before in other videos. So we're using exactly the same PLC program what we used before, and also we're going to, in the end of the video, achieve that result. So basically it's going to do all the tests as required in functional specification. That protections needs to be tested, and that is what we have achieved here by putting all action units in this test case, and in the end we're getting that result. So as you can see, it goes through all the tests as per this tree. So let's get into this. So what I'm going to do, I'm going to show you how to create this test case step by step. For this, I'm going to create a new project. Action set, which I'm going to call test presets. Start adding action units. So I start with the inputs I can simulate a healthy state. So that is set healthy inputs. Just save this. And I'll create all the tags here because just it's a little bit easier here, and also I can give it descriptions which are searchable, and eventually I'll know what particular tag I'm looking for. Other tag names are self-explanatory, so we don't need to have extra descriptions here. So let's go back here and let's start. So 0 is our start, value 0. For stop, it's 1, we want to have 1. Let's add one more. So at this point, we finished with our healthy inputs. We just can save this. I will probably change that state to project critical because if we cannot write by any reason these tags in the PLC, we need to stop all the projects so it's not continuing. Save. And let's continue with our test presets. So next is going to be totalizer comms fault. Find this tag with heartbeat fault. It must be 1. Yeah, and I save this. And next, to make it healthy, I will need to add a heartbeat. Totalize healthy comms. So here we need to have totalizer heartbeat. press reset push button. So save. Let's continue with our alarms now. So let's create new action set, give it a name, protection alarms. Sound pretty good for me. Let's create this action set. Inside the action set, the first thing I recommend always to do is to do check. Let's say check health system healthy. That's the name. And here I'm going to do the first thing is to check the system healthy. So what I want to do is make sure it is all healthy, and I want to that set critical. So if it is not healthy, we're just not continuing with this because nothing will be to test against. Next, simple version of functional specification where we see the protections and their requirements for protections. So I will start with that and I will do the following. So I will just follow these steps as I'm going to build our action units. Thermal overloads. Let's do this. Let's start with the first thermal overload. It's going to be unit test. All right, let's add that one. So here we basically want to test if the pump one, pump one, yeah, here we go, pump one thermal overload goes to 0, which is input will disappear. Let's say it's here. Go back to our mapping LC. That input is now on, but if it goes away, which is not healthy state, what we want to see? We want to see that is our system healthy becomes 0. But what time it should take? It usually says in our functional specification, and here it's a 50 millisecond. I guess it's just a filter, so 0.5. So it is 50 millisecond. I think we're all good here. With the monitor for no change, what I probably add here and in others unit tests, I will test that is totalizer fault doesn't change. So we know now that it is 0 because the system is healthy and we want to stay it like this. So all our unit tests should not interfere with the heartbeat. So we just make sure it hasn't been changed. And by the end of the execution, we would like to put it back to the healthy state. So because that's going to be 0, it's unhealthy. We're going to put it back to the healthy state. And to healthy state, we just need to toggle reset, which is reset is our input 2, and we toggle to 1. And let's do it on half a second, and we save. So I think at that point, I would like to give it a go and do quick test of the current setup. So I expect everything will be green, and I expect that is our trip on pump 1 TOL is going to pass. Okay, let's run the test. It's trying to connect to PLC and it cannot connect to this IP address. That's exactly what I forgot. I forgot to set an IP address. And I will just have to run it again. So now we can see it's all connected. It's going through all test presets and went through our protection alarms and did the check. Now I'm going to go through the rest of the protections and add them here in the test case. So here I will just do it duplicate, so I don't need to do too much work. here I'm going to add action, which is going to be unit test. And here is going to be a little bit tricky, right? So what we need to do is to simulate pressure loss. So basically we need to say that this pump is running, but we don't have pressure within 3 seconds, and pressure is below 10. So we know that is our values zeros. No, we don't. We forgot to add it here. So what we have to do here, we have to add a bit more. So we need to put pressure to 0, and we need to add level to 0. So we should know that is that values in the beginning of the test are zeros. So when coming back to here, we know that its pressure is 0, and if, as you can see, at state start pump, so it's a state 1, we have to start the pump and wait till 10 bars. So that is where we're going to see this pressure loss. So how are we going to simulate this? I'm going to say state 1, and after 3 seconds, we're going to have system have a fault. So that is what we're going to see. State goes to 1, and after 3 seconds, we didn't get any pressure. It should trip here, right? I will add heartbeat here too. But what I also would like to do is to actually check that this pressure loss will occur. I will go to our PLC Logic and I'll find this pressure loss. So this is our pressure loss tag, and I will add it as an additional output. So our pressure, we don't have one yet, so we need to just create. So just create it in our tag list here. And we're going to see that in 3 seconds, it will become 1. So we're going to test both things. So that's what we want. But in the future, we don't really need this. We just need to make sure that this healthy state becomes 0, right? And I forgot about that reset here. Let's put reset toggle to 1, save, right? So continue with more actions. Let's see that, how we're going to simulate that. So simulation of flow loss is combination of sequence and some values. So as you can see, when we start the pump, we wait for 10 bar, we open solenoid, and that is solenoid 1, and that is when flow should go. So that means if I will run the pump, which is state 1, and the solenoid will be, so, and I need to have pressure, so solenoid will be open, and no values changed here, that means the loss of flow. And I go back here and I'm going to say that is we need to have state should be 1. We need to have pressure, which is going to be 11. It says wait 10 bars. And next is going to be, we have to see the system fault after, I'm just trying to calculate how many seconds. So it says here after 3 seconds, but also we have to wait for 4 seconds before open the solenoid. So it's altogether 4 and 3 should be 7. So after 7 seconds, it will trip. Okay, so let's continue here at our reset buttons. Leave it 1 second. All right, let's continue with the flow number 2. So it's and here I need to do the following. I think we probably should see if it is open. We need to run the liquid out. So, and stop it in state 4 if it is, okay, so we have to have maintain the level, and level when it's below 200 millimeters, it's going to stop pump. All right, so level, and we set it to 201, just have a little bit above the value when it's closed. And we have to do here state to 4. So here we have enough level and we have state 4, and the pump should run, right? And pump will run, but we will still have a fault just because there is no flow. We don't have values coming from the pipeline too. So that is going to trip on loss of flow in pipeline too. And to confirm this, it's 3 seconds too, right? Just to confirm this, just 3 seconds. And just to confirm this, I will go to grab this particular tag where it is in the mixer tank, and I think it's here somewhere, pump flow loss. All right, so this is that tag. I'll just copy this and I will add it here. So just create one, and that should become 1 after this 3 seconds. But I just noticed something. I have forgotten to change this to 0. So this healthy becomes 0 in 3 seconds, and flow loss fault become 1 in 3 seconds. All right, let's continue. And our totalizer should not fail. And when it's finished, we have to do reset, simulation of reset. So that is how we test and after reset. So next is going to be another action unit. Almost last. I just want to open that to see. So low level, it's going to be when it's lower than 100 mil at state 3. So what we have to do, I have to have level, and it's going to be 99, right? State, we need to see what state it is. So it is at state 3, so when its mixer is running. But also I noticed that we have one more condition here. Totalizer must be more than 50 liters and close. So I just want to make sure that as we run on the state 3 and nothing else happening. So I will add here line 1 process value to, let's say, 51. So make sure we have that value is higher. So we closing solenoid 1 and pump, stopping pump 1. So running mixer. And now state is mixer. So that is how it's happening. And state 3, it's less than 100 and for 0.5 millisecond, for 0.5 second. So that means the system becomes not healthy in 0.5, right? So what we're going to add here, as usual, make sure we don't have this heartbeat faults. And when we finish, we just press reset button. It's 1 second. And last one, it's going to be a unit test. So I'll save this, and at that point, it looks like we finished with all our alarms. And what I'm going to do, I'm going to run our test. Right, to do this, I'm just going to open our test runner. I'll just clear the output log, and I will run the test. So as you can see, we go through connection. Next is presets. It goes pretty quickly. So go to protection alarms now. Check all thermal overloads, pressure loss, flow loss. It takes a bit longer. It's 7 seconds. So as you can see, it just goes through that. Now it is flow loss in pump number 2. It's pipeline 2. Trip on lower levels. Right. So we have trip on high level pass. So what happened here, healthy with value 1 hasn't changed to expected value 0. So it's basically didn't trip on low level. So that's one of the perfect examples why we need this software. And we can check the logic in a PLC, but also could be a problem in describing the test set. So it looks all correct for me. I think at that moment we probably should go in PLC and see what's happening in PLC. So a tank level, actually I'm right page, mixer. Here we go. This is what we're looking for, right? So that should be happening when we have request and level is below 100. So we're expecting this to become 99 at some point, and that should be on, right? So let's watch this and run this. Okay, let's run. So we're opening connection, going through all protection alarms, all trips, pressure loss. We don't worry about pressure loss. Flow loss, let's keep watching. I just want to see this coming up. It's 200, it's too much. Flow loss, oh, here we go, 99. It was on, it was 99. And if what do we have here? 0.5, so it's 500 milliseconds, and we have 1.5. And let's go back to our functional spec. It says 0.5. So that is a perfect example when we have maybe copy and paste from here or here, the blocks, and we just changing values and forgot to change presets. So in our case, PLC must have half of second as per our functional spec. So let's go back again and try to run this again. And I think that is caused that issue. So let's run again. And we see it goes through all the alarms as usual. The presets first, alarms, thermal overloads, pressure loss, flow loss for pipeline 1. We're going to have flow loss for pipeline 2. And next one is 99. Here we go. Look at this. Now it is 0.5 seconds. And we have all of the alarms, or all of the alarms tested, and all of the units went with the pass So that's exactly what we're looking for. And we just tested that protections of that application with PLC Logic Prover. And I'll talk to you next time. See ya. Bye-bye.